Hi everyone, in this video we're going to look at factorizing exponential expressions. Now as you know, factorizing is a helpful tool for simplifying fractions where you have more than one term in the numerator or the denominator. It's also quite a helpful tool to have if you're trying to solve equations. So let's get going. Now if you look at the laws of exponents, you should notice that all the laws involve either multiplying or dividing. Remember, if something's raised to a power, that's the same as repeated multiplication. However, what do you do when you need to add or subtract? That's where things get a bit tricky. So what we're going to look at is we're going to look at some examples of adding, and then we're also going to look at examples of adding or subtracting two terms where you can factorize them. Now you should know that when you're adding or subtracting, you can add or subtract like terms together. So if I look at these examples, in the first example, my like terms are x to the power of 5. So if I'm adding x to the power of 5 plus x to the power of 5, I'm going to get 2x to the power of 5s. In the next question, I now have a constant as the base, but this doesn't change the situation at all. I still have two like terms. So I've got 1x to the power of 5 plus another x to the power of 5 is also going to give me 2, but this time I'm going to have x to the power of 5. Now in the next question, again I've got like terms. I've got both of the terms have 3 to the power of n. The first term is 5 times 3 to the power of n, and the second term I can think about as 1 times 3 to the power of n. So the way I can write that is going to be 5 minus 1 is 4 times 3 to the power of n. Now what we're going to look at next is how to factorize questions like this. So a different way I could write this is I could use 3 to the power of n as my common factor. The first term will be 5 in the bracket, and my next term will be 1 in the bracket, and that simplifies to 5 minus 1 is 4 times 3 to the power of n. Now remember, if terms are not like, you cannot add them together or simplify further. So if I had something like 3 to the power of x plus 2 to the power of x, these two are not like, and we cannot simplify further. You may be tempted to write this, 3 plus 2 to the power of x. But that means something quite different, because this will be 5 times 5 times 5 times 5. How many times? X times. And that's different from 3 times 3 times 3 times 3, x times, plus 2 times 2 times 2 times 2, x times. Now we're going to start looking at factorizing. Let me start with just constants. So I've got 10 to the power of 8 plus 10 to the power of 10, and I want to factorize this. So let me break this up. I can see that my highest common factor is going to be 10 to the power of 8. So let's write down 10 to the power of 8, and I'm going to break the expression up. The 10 to the power of 10, I'm going to write as 10 to the power of 8 plus 2. Now I can break up that 10 to the power of 8 plus 2 as 10 to the power of 8 times by 10 to the power of 2, using the first law of exponents. A to the n times a to the m is equal to a to the power of n plus m. Now furthermore, I can now take out my common factor of 10 to the power of 8. And I know that my second term is going to be 10 squared. And my first term in the brackets is going to have to be 1, because 1 times 10 to the power of 8 gives me 10 to the power of 8. Now 1 plus 10 squared is 100, so I'm going to get 10 to the power of 8 times 101, and I could write that as 101 times 10 to the power of 8. Now most of you wouldn't have done it that way. You might have worked a little bit faster and just gone straight away, 10 to the power of 8, 1 plus 10 squared, and then got your answer. But the reason I'm breaking it up so slowly is so that you'll understand the next example. Now we're going to look at factorizing, where I have exponents that are variables. So firstly, I'm going to break up my first term so that I can see what the factors are of the first term, plus 7 to the power of x. Now, the reason I can do that is because of my first law of exponents says if I've got the same base multiplied with another power with the same base, I can add the exponents. So if I work in the other direction, if I'm adding exponents, I could split up into two factors. Now, if I look at my expression now, I can clearly see what my common factor is. So my common factor is going to be 7 to the power of x. My first term in my brackets is going to be 7. And my second term is what times 7 to the power of x is 7 to the power of x? It's going to be 1. So 7 plus 1 gives me 8 times by 7 to the power of x. Some people don't like doing the step where you show everything broken up. And some people go straight from the first step to where I've shown. You're welcome to do that if you'd like to. Let's look at another example. Again, I'm going to break things up. So my first term doesn't have much going on. My second term, I'm going to break into two separate factors. Now, my common factor is 2 to the power of n. So I'm going to get 2 to the power of n and 5 minus 2 to the power of negative 2. Now, in the brackets, I just have constants, so I can work out what they are. 2 to the power of n, 5 minus a quarter. And so that's going to give me 2 to the power of n. 5 minus a quarter is 4 3/4. And so if I write that as an improper fraction, I'm going to get 16 plus 3, 19 out of 4, like that. Now, it would be suitable to write my answer like this, 19 out of 4 times by 2 to the power of n. Or if I wanted to go on further, I know that 4 is 2 to the power of negative 2. So I could write the last step, if I wanted to, as 19 times 2 to the power of n minus 2. Either of those are correct. To end off, let's look at one that's a little bit harder. Now again, let's split up what's going on here. So I get 2 to the power of a times by 2 to the power of 4 plus 6 times by 2 to the power of a times 2 to the power of 1. Now, if I take out just a common factor, I'm not going to take out the highest common factor. I'm just going to take out 2 to the power of a as the common factor. I'm going to get 2 to the power of a. First term in the brackets is 2 to the power of 4. And second term in the brackets is 6 times 2, which gives me 12. I can then simplify that. 2 to the power of 4 is 16 plus 12. And so I get 28 times 2 to the power of a. Now, another way I can attempt this question is by taking out the highest common factor. So if I go from my first line, let's break everything up a little bit more. 2 to the power of 4, plus I know that 6 as primes will be 3 times 2 times 2 to the power of a times 2 to the power of 1. So at the moment, my highest common factor is going to be 2 to the power of a times 2 to the power of 2. So that means my first term is 2 squared, and my second term, I've already taken the 2's out, so I'll get plus 3. So that's going to give me 2 to the power of a times by 2 squared, which is 4, times 4 plus 3, which is 7. So I'm going to get 2 to the power of a times 4 times 7, and we know that 4 times 7 is 28 times 2 to the power of a. So it doesn't really matter if I took out the highest common factor or not. My suggestion is as long as you take out the common factor that has the variable in it, you should be fine. So in the next video, I'm going to look at simplifying fractions that have exponential expressions in them. In particular, exponential expressions that are either 2 terms in the numerator or 2 terms in the denominator, and we're going to use this tool of factorizing to help us simplify those expressions.